So far, we explored the common ways that users, especially users of assistive technologies, browse, access, and engage with web content. Now, let's take a closer look at behind the scene of this interaction flow. Simply put, when an assistive technology user requests a web page, several key components work together to create the best user experiences possible for them. Here is a high level overview of the steps and the process that is happening within the flow. Okay, open a web page URL being requested. Web browser collect all the web assets regarding to that web page and parse them together to create something called document object model tree. And then from the document object model tree, we have accessibility API. Accessibility APIs is being offered by the operating systems of the smart device that the users with the special needs is leveraging. So assistive technology installed on the operating system creates something called accessibility API. And through accessibility API, end users are being informed about the text content, accessible name, role, state, relationships, and some other essential information. This is a super high level overview that I went through. There are so much details and interesting information hidden here. So let's break it up. As many of us already know, web pages are being created based on building blocks. Structure and content are coming from HTML file. Anything to do with the styling and presentation characteristics, they're being generated from CSS files. Operation, functionality, and behaviors are also added to a web page via JavaScript. Now, open assistive technology device users requesting a web page. A web browser, including Chrome, Firefox, Edge, Opera, and etc., loads the web assets from the server. These web assets are the HTML, CSS files, JavaScripts, images, any other references and resources for the web page. Then the web browser processes the web content and creates a document object model, which for short it's being called DOM. DOM is the structured presentation of the content and elements on the web page. As mentioned, structure and content are coming from HTML file. So for example, if we take a look at this code snippet, we have the HTML that it contains the title of the browser, it contains heading level 1 and a paragraph. So web browser parse the content and they create DOM tree. Okay, and this is how it looks. A DOM tree always starts with the document object at the root level. And then every HTML element becomes a node inside the tree. We have parent nodes such as head and body, and we have children nodes such as h1, paragraph, and also text nodes. For example, hello world, and this is a paragraph, right? So one more time, DOMs are being generated when a browser loads web pages alongside with all the associated web assets and resources together. A programmatic presentation of the HTML content in a hierarchical tree of objects. This is DOM. Talking about DOM tree, we also should be aware of DOM API, which is Document Object Model Application Programming Interface. Okay, is a programming interface as it says. It's a collection of methods, properties, functions, and objects that empower developers to access, modify, and manipulate the DOM tree. Okay, whenever developers use get element by ID, append child, remove child, and other functions, it means they are using JavaScript to get the hold of a node within the document object model tree and change and modify it. In order to make sure that we are clear about DOM tree and DOM API differences, let's take a look at this table. Okay, DOM tree is a static structure. Okay, it just represents the HTML content and element. Okay, it describes elements, attributes, and the content of a web page in a tree-like structure. Keep in mind, data structure. Okay, it's being created by the browser. However, DOM API is a set of methods to manipulate and change the DOM tree. All right, so it's a set of function, it's operations, it's properties and objects that give us ability to change and update DOM tree structure. Even though JavaScript can change and manipulate DOM tree via DOM API, but DOM API itself is not an efficient API for assistive technology to interact with. Okay, um, browser and assistive technology communicate through another set of tree and API which is dedicated and explicitly designed for assistive technology. It's called accessibility tree. Accessibility tree is a subset of DOM tree. Okay, it's explicitly designed for assistive technologies to augment or replace the existing UI for the application users. Okay, so it's both way. It works from the user to the operating system and from operating system bringing back information to the user. Accessibility tree provides a simplified and annotated view of the DOM. Okay, it only focuses on the elements that are relevant and important for accessibility. Okay, keep these in mind. Semantic meanings, roles, labels, relationship, state. These are important pieces of data that assistive technology users must be aware of. On the other hand, Accessibility API is a set of system level interfaces between the browsers and assistive technologies, which is being provided by the operating systems. Okay, so it means the OS of the actual device that users are interacting with the web page will provide the Accessibility API. It allows assistive technologies to interact with applications, including web browsers. Accessibility API transmits information, content, and events from the browser's accessibility tree to assistive technologies and receives input from their end users, bringing it back to applications. As it was said, is a two-way interaction. Excellent. Now that we have completed reviewing some of the accessibility related terms and definitions, let's go back and take a look at the flow of information between web browsers and assistive technology users. So we mentioned when a web page is being requested from any user agent, including web browsers, HTML, JavaScript, CSS, image files, and any associated web assets regarding to that web page is getting loaded and parsed within a web browser to create the DOM tree. Then developers had some methods and properties and functionalities to use DOM API to update and manipulate the information provided within DOM tree. Okay, everything is happening between the web browsers at this point. All right, then at the very other end, we have the assistive technology users which interact with a device, and that smart device has an operating system. So operating systems offer accessibility API because the DOM tree and DOM API is not efficient to be leveraged directly, and none of the developers can use JavaScript to directly impact the accessibility tree. So we had another set of information and interfaces called accessibility API. So the accessibility API was created within operating system, and it fills the gap between the assistive technology information that are required with the DOM tree and DOM API. All right. So assistive technologies require a couple of metadata that we briefly touched. Some of them are accessibility name, accessibility label, role, value, state. These are all the metadata important about each of UI element which is exposed to accessibility tree. All right, now I want to dedicate a few more minutes to review what is an accessible name. What are we talking about when we say role of an HTML element? What about the state of an element within a web page? As mentioned, accessibility API conveys various type of information to assistive technologies, one of which is name. Name is a label or identifier for a user interface element which is visible to the accessibility tree. This accessible name or accessible label can be driven from the visible text content, area label by, or alternative text or associated label tag. The name property is essential for form controls, images which are links or buttons, and interactive elements. So going through a couple of examples. So imagine we have a button tag that has ARIA label implemented on it. So if the ARIA label says submit form, our button has the name of submit form. So therefore, the accessible name or accessible label of this button element is coming from the ARIA label value. Similarly, if we have an image tag and our image tag has an alternative text, the accessible label or accessible name of that image is the value inside the alt attribute, which we call it alternative text. Looking at a label tag, so label tag can enclose the visible text inside it, or it can use an ID and for association to connect a label to an interactive form element. But in this case, we have the actual full name enclosed inside a label tag. Therefore, the following input field will have the full name as the accessible label or accessible name for that control. Another piece of information that accessibility APIs transmit to assistive technology, it's a role of an element. Role describes the function of an element on a web page. It tells assistive technology what type of UI component the element is and what does it do. We call it what type of affordances it has. So for example, if it's a button, it can be activated. If it's a heading, it's just for information. There is no interaction connected to it. If it's a link, it can be activated or clicked. And for form elements, they can be filled out and a form can be submitted, right? So role overall talks to the type, what type an element is. So for example, a heading level 1 is a role of heading. A button has the role of a button. A link has a role of link. Okay, what type of an element? The third piece of information that is getting transmitted to an assistive technology via accessibility API is actions. Actions represent what the user can do with a particular element. As you recall, when we have a link, the type is a link, the action is clicking. For a button, the type is a button, but the action is pressing. For a text input field, the action is editing, which means entering text inside the field. Okay, more examples. So clickable. A link can be clicked, then it should be announced as clickable. For a text field or content that is editable, assistive technology users will communicate editable. This is happening via Accessibility API. It's conveying that this text box can be edited. Therefore, user can input or change the text and value inside it. The fourth piece of metadata is value. Value of an element represents the current data or selection in certain type of elements, such as form inputs, sliders, progress bars, or selection control. Okay, to simplify what it says, not every single UI element has value, but some of them do. Okay, so for example, if we are looking at a progress bar or a carousel slash a slider, so for example, if we have um, 4 slides inside one slider, and currently the slide number 2 is being displayed, then we can have aria dash value now for 50, which just represent the value of the component for the slider is 50%. Okay, similarly for a progress bar. So if a multiple step process is being fulfilled, the progress bar can indicate some percentage. So for example, 10% complete, 35% complete, 76% complete, right? So depending how many steps is included inside the progress bar, the current value of at the moment is the value that is associated with that progress bar. Okay, next example. So text input field. We just went through the editable option for a text field. So any text value inside the text box can be considered as a value for that element, which the type of element is a text box. So I want you to be clear about the difference between type and the value. Again, type. The fifth piece of information that is getting conveyed to assistive technologies is the state. The state of an element indicates whether that element is enabled, disabled, checked, unchecked, selected, unselected, expanded, collapsed, and other states. Assistive technologies rely on state, this type of information, to convey the current status of an interactive element for their users. So, for example, if a button is disabled, then users are unable to interact with it. If an accordion is expanded, then the value RU expanded is equal true is correct, which means we have a menu with a submenu or an accordion which is already open. If a checkbox is checked, it means the value of the checkbox is equal to true or number 1. If it's unchecked, it means the value is 0. The next piece of metadata is description. So accessible description provides additional information related to an interface. So it's a complement to the accessible name. Okay, accessible description is not a replacement for the accessible name, but instead is extra context. It clarifies the purpose of an interactive element. Okay, so the accessible description might be visible, might not be visual perceivable. Okay, just very similar to accessible name. It could be presented visually to all the users to leverage, or it could be only programmatically available to assistive technology users via ARIA described by attribute. Okay, now let's spend a few minutes to see what are the examples of description. Okay, so for example, any message that we see on a web page which contains a form, such as form fields in the error states are all required to fill out. Or password must have 8 to 12 characters, letters, numbers, and etc. Or even any acceptable format for a date field. All of these are additional information about interactive element. They're not the actual replacement for the date of birth or password or error messages for a form field, but they are additional information about them. The seventh piece of metadata that Accessibility API conveys to assistive technology is relationships. The relationships describe how elements are connected or related to each other. It could be grouping elements, labeling elements, associating elements that are not immediately adjacent in the DOM. Okay, let's unpack this. So for grouping elements, let's consider group of radio buttons. Okay, so for example, for a single day booking, there are 7 days of a week within radio buttons format. Okay, and you're able to only book one of the radio buttons. Okay, so the relationship between these group of elements is important. Okay, labeling elements. So for example, when we use aria labeled by or label element, so we are associating label with a form control or any interactive element. Okay, so when we talk about aria described by, that helps us to associate a description to a UI element. So that association between the description and the interactive element that talks about the function or purpose of that element, this is a relationship. Similarly, when we have ARIA owns or ARIA controls, these are the attributes that are being often used within forms, for example, for error messages and or for menu and submenu. All right, so sometimes, for example, for very complex global menu, we have level 1 of the item within the group of navigation, but then the level 2, level 3 elements as a submenu items, they are being injected to the page. So they don't actually exist when the global navigation load. Okay, so when we have items located in different places within our HTML, we can use ARIA owns, ARIA controls, and other sort of associations to indicate that these are elements that even though they are not adjacent inside the DOM or HTML code, but they are related to each other. So we indicate the relationships between these elements. While there are still a lot of concepts to learn and explore, this is it for today, and I would like to thank you again for taking the time to continue your accessibility journey with me. Until the next session, goodbye.